Welcome to this Junior Cycle Higher Level Maths revision video. In this video, we're going to revise long division. We're going to look at algebraic long division when we have a cubic. This is an x to the power of 3. Algebraic long division when there are missing terms. And also using algebraic long division to simplify algebraic fractions. We use this when we're not able to factorize. Just before we start, I think it's a really good idea that you revise basic long division. So doing long division with numbers. There's a lovely video linked below. It's not my video, but I definitely recommend that you watch it as a little bit of revision before starting into the algebraic long division.
Okay, so here's our first example. We have a cubic here, x cubed plus 2x squared minus 7x minus 2 divided by x minus 2. So let's first of all talk about long division. So when doing long division, it's a good idea to have this little mantra. So the mantra I use is divide, multiply, subtract, and we'll keep doing these three in a loop until we get to the end of the question. What I find is using that mantra helps us to make sure we do everything that we need to do. Sometimes we can forget a step, but if we're constantly saying in our head, divide, multiply, subtract, we're less likely to make a mistake. So let's set up our long division here. So we have x minus 2, and we're going to divide that into x cubed plus 2x squared minus 7x minus 2. Now, I would always use a rough work column here to help the long division, specifically for the divide part. If you are fully comfortable with the division and you can do it in your head, that's absolutely fine. But if you are struggling to see it, it can be a good idea to start with the rough work column, and maybe then as you get more confident you'll stop using it. I'm going to use the rough work column for this example anyway. So our first step is to divide. So we're going to divide x into x cubed. So what we're trying to do is x cubed divided by x. So straight away you might see what that gives you, and that's fine. But if not, we can say that x cubed is x divided by x. So straight away we can see that there's an x above and below the line that can cancel, and that leaves me with x squared. Okay, so the rough work column can be useful. So let's put an x squared in here. So that's our divide step done. Now we're going to do our multiply. So even though with our division we focus on the x and the x cubed, when we do our multiplication we multiply both terms. So x squared by x gives me x cubed, and x squared by minus 2 gives me minus 2x squared. Okay, so there's my multiply done. And the final step then is subtract. So subtract for us really is going to change our signs. So if I have a positive here, it's going to become negative. And here I have a minus 2x squared, so if I subtract that, I'm basically changing the signs, so it becomes positive. Now, I would advise you to do that in another colour so that if something goes wrong and you have to go back and check your work, you can see really clearly that you've done that subtract, this subtract step. So x cubed minus x cubed will cancel, and plus 2x squared leaves us with plus 4x squared. Now at this point we'll bring down the minus 7x, and we start our mantra again. So let's do our division. So our divide, we have 4x squared divided by x, which is 4x divided by x, and that will leave me with 4x. So it's a positive 4x here. So now we've done our divide, let's do our multiply. Plus 4x by x is 4x squared, plus 4x by minus 2 is minus 8x. So now we've done our multiply, let's do our subtract. So this becomes a minus and this becomes a plus. So minus 7x plus 8x gives me 1x, a positive 1x. And I bring down my minus 2. So our final step, so apologies now, let's tick off the subtract. So our final round, so we're going to be doing our divide first. So we have a 1x divided by x, and that gives me 1. and it's going to be a positive 1. So now we do our multiply. So we're left with 1x minus 2. And that's my multiply done. And our last step then is subtract. So we get a minus here and a plus here. So we're left with no remainder. Okay, so this is my remainder. So that was our final subtract. So it's divide, multiply, subtract, divide, multiply, subtract. If you were asked this question, simplify in this way, you would expect for this to work out evenly. We will see questions where it might not work out evenly, but if you were just asked a straightforward long division, you would expect to end up with 0 remainder. Okay, so let's look at example 2. So this is missing term. So we still have a division here. So let's set up our little mantra. So we have divide, multiply, and then we have subtract. Okay, so let's take a look at our actual division here. So we have 3x minus 2, and that's going to divide into this polynomial here. If we just take a look at this polynomial here, and it's a cubic, so just for 1 second, so I'll just highlight here exactly what we're looking at. We have a 36x cubed minus 28x plus 8. So it might look a bit strange to you. You might realise why it looks strange, you might not. But the reason that we are highlighting this or doing this as an example is because when we have an x cubed, we would expect the next term to be an x squared. Then the next term to be an x, which we have, and the last term to be a constant. So it seems that we're missing a term. So we're missing the x squared. Now when we go to do the long division, this can cause problems just because of how we work through it. And the easiest way to get around this is to put in an x squared. Now obviously we can't change this expression, but what we can do is when we're writing it down, instead of ignoring the x squared, because there's none, I will write that I have plus 0 x squared. So basically it's going in like a placeholder, and this will just help to make our sum that little bit easier. Okay, so if you are missing a term, and it's important to always look at your expression to make sure that that you're not missing a term, and especially if the term is somewhere in the middle, it's a good idea to write it in as a placeholder with a 0. So other than that, we can proceed just like we did with the last time. Let's have our rough or column. So we're going to do our divide first. So our divide is 36x cubed divided by 3x, which gives me 36x all over 3x. So definitely an x will cancel. I know 3 goes into 36 12 times, so what I'm left with is 12x squared. So we have 12x squared here, so we've done our divide part. Let's do our multiply. So we're 12x squared by 3x is 36x cubed, and 12x squared by minus 2x is minus 24x squared. Now if we hadn't got that 0x squared in there, we'd have our x squared under our x, and we may become confused. Now it's still absolutely fine to do it like that, but this method will lead to the least confusion. So last step then is to subtract, so we'll change this to a minus and then this to a plus. So subtract is done, and we are here now with the 24x squared. So we have 0x squared plus 24x squared just gives me 24x squared. And minus 28x, we need to bring this down. And we go back to our mantra, so we do our divide. So we have 24x squared over 3x. So that's our division, so we're going to have 24x over 3x. So there will be an x that cancels, and 3 goes into 24 8 times. So we're left with 8x. So we'll have a plus 8x. So that gives me 24x squared, and plus 8 by minus 2 is minus 16x. So that was my divide and my multiply. So let's go along to my subtract. So this becomes a minus, and here becomes a plus. My 24x squareds cancel. And I'm left with 28x plus 16. So I get a minus 12x and a plus 8 here. So I've done my subtract. So now I go back and do my divide. So I have my minus 12x divided by 3x. The x's cancel. 3 goes into 12 4 times, but be careful, there is a minus in front of that, so I get minus 4. So that's my divide done. Let's do my multiply. So minus 4 by 3x is minus 12x. Minus 4 by minus 2 is plus 8. So there's my multiply done. And the last step then is my subtract. So the minus becomes a plus, and this plus becomes a minus, leaving me with 0, which again, if we remember from the last example, that's my remainder. Okay, so it's important to note then that our actual answer is this. So when we simplify it, this is our answer. Our answer is what is on top here. Okay, so our answer is 12x squared plus 8x minus 4. So you'll notice that even though we were missing a term to begin with, we have an x squared, an x, and a number. Okay, so example 3. So this is simplifying an algebraic fraction. So if we look here, we have a fraction like we have seen before. If you have not yet revised your algebraic fractions, I would advise that you do so. Our method for simplifying algebraic fractions was to factorise the top line, if possible, and to factorise the bottom line, if possible. So that's okay if we have a quadratic or something similar on the top, but in this case we have a cubic. Now, in order to factorise a cubic, we would have to use trial and error and then long division, so it's not an easy task. So instead of trying to factorise it and then doing the simplifying, it is actually easier to read this as 3x cubed plus 13x squared minus 18x minus 40 divided by, so actually using this line here like a division sign, 3x plus 4. So actually what we're going to do is we're going to use 3x cubed plus 13x squared minus 18x minus 40 divided by 3x plus 4. So we're going to use this like a long division sum. So let's write down our little mantra. So divide, multiply, subtract. And we'll have a little rougher column. If at this point you're feeling confident to do your division without a rougher column, that's absolutely fine. I'm going to keep using mine. So 3x plus 4 divide into 3x cubed plus 13x squared minus 18x minus 40. So let's do our divide. So we have 3x cubed divided by 3x. So we have 3x x divided by 3x. So the 3's cancel and an x also cancels. That gives me x squared. So there's my division done. So let's move on to our multiply. So x squared by 3x is 3x cubed. X squared by plus 4 is plus 4x squared. Okay, so now let's do our subtraction. So this becomes a minus and this becomes a minus. So 13x squared minus 4x squared gives me 9x squared. Let's bring down our minus 18x. Now, so we have 9x squared divided by 3x, which gives me 9x divided by 3x. So the x's cancel and 3 goes into 9 3 times. So that what that leaves me with is 3x. So I have plus 3x, so that's my division done. Let's do my multiplying. 3x by 3x is 9x squared. 3x by plus 4 is plus 12x. So now let's do our subtraction. So this becomes a minus and this becomes a minus. which leaves me with minus 30x, and bring down your minus 40. And let's do our final division. So minus 30x divided by 3x, so the x's cancel, and 3 goes into 30 10 times. So what I'm left with is minus 10. So minus 10 by 3x is minus 30x, minus 10 by plus 4 is minus 40. So that's my multiplication done. So now let's do our final subtraction. And that leaves me with 0, which remember is the remainder. But again, it's important to remember that actually our answer is x squared plus 3x minus 10. So that's actually my solution, or my answer. Okay, is that top line there. So now here's a more practical example of where you would be required to do some long division, but it's not very clear that it's long division. So show that x minus 1 is a factor of x cubed minus 2x squared minus 5x plus 6. Hence find the other two factors. So it's important here to remember, one, what a factor is and how we verify that something is a factor. So the example I gave you at the very start of this video was, if I asked, is 5 a factor of 10, how would you say yes or no? And the reason is we'd say yes, it is a factor because 5 divides evenly into 10. So it divides in 2 times, there's no remainder. So we're going to use the same method here. So in order to do the verification that x minus 1 is a factor, we're going to actually divide x minus 1 in to x cubed minus 2x squared minus 5x plus 6. Now, in these questions, if it says show that, it will be correct. So when you do it, you should get no remainder. However, you might be asked to check if, or to verify if x minus 1 is a factor. So in that case, it may be a factor, it may not be. But in this case, show that it's a factor. We are very sure that we should show no remainder. So x divides into x cubed x squared times, so we're left with x cubed minus 1x squared, and then I change my sign, so I do my subtraction, so we cancel here, so this is minus x squared, and we bring down minus 5x. So now my division, x divides into minus x squared minus x times. If you're not comfortable with this division, do your rougher column, plus x, and now we do our subtraction, plus and then minus 6x, and we bring down plus 6, and x divides into minus 6x minus 6 times, so minus 6x plus 6, and my last step is my subtraction. Now, you need to be really clear here, so we're going to say, therefore, x minus 1 is a factor of x cubed minus 2x squared minus 5x plus 6, since it divides in evenly. And what I mean by that is no remainder. Okay, and it is important that you do that. You need to answer the question. Show that it is a factor. You know, if you're just blindly dividing, they may say, well, you haven't verified, you haven't told us that you understand what you're doing. So show it. Therefore, x minus 1 is a factor of this since it divides in evenly. Okay, so that's the first part done. Now, we have a hence, and hence for us is a really important word. In most exam questions, it will say hence or otherwise. Sometimes it will just say hence, and what hence means is using the previous part. So it says hence find the other two factors. So what's important here is our answer. So remember, our answer is this one up here. So basically what they've told us is, or basically what we have discovered is, x minus 1 by x squared minus x minus 6 gives me this polynomial here. Now, if you remember back to your prime factors, we were breaking our factors down to the lowest possible number, to the smallest number that we could, and they were our prime numbers. They couldn't be divided anymore. So similarly with algebra, we have this factor here which cannot be simplified any further. It cannot be broken down. However, this one here, so what we got when we did our long division, that actually could be broken into two more factors, and in order to do that we're going to factorize it, and we're going to factorize it using the guide number method. Now if you factorize it another way, that's absolutely fine. I'm going to use the guide number method here. So the factors of minus 6, we're going to have minus 3 and a plus 2, so we're going to have x squared minus 3x plus 2x minus 6, and we're left with x minus 3 plus 2x minus 3, and then x minus 3 is common, and then x plus 2. So actually the factors are x minus 1, which we were given, x minus 3, and x plus 2. So we have to use our answer, so hence, to find the other two factors. So basically we take our answer and we know that x squared minus x minus 6 is a factor, but it's not the smallest factor. We can break that into its own factors. So that is how we would work with if we were with a question where we're asked to show that something is a factor of a polynomial. So this is the last example that I'm going to do. So very similar to the previous example, it's asking me to verify a given root. So I suppose there's two ways that we can look at this, and I'm going to do both ways. So we have been given this x equals minus 4. So that is a root of the equation, so it's an answer. So they want to show that that is a root of 2x cubed minus 7x squared minus 42x plus 72 equals 0. So the most common way we would have had to date of doing this is using our subbing in. So it'll be 2 by minus 4 cubed minus 7 minus 4 squared minus 42 by minus 4 plus 72 equals 0. And when you work that out, you can do as many steps you want, but you will get 0 equals 0. So therefore x equals minus 4 is a root. Okay, so that's absolutely fine to do, but then when we get on to the next part, hence find the other two factors, the work we've done hasn't been hugely beneficial. So an alternative method of the first part to show that x minus 4 is a root is if we said x equals minus 4 is a root, then x plus 4 is a factor. And this is very important for you to understand how we get from being a root to a factor. So at the very start, I kind of gave a really quick revision of going from a factor to a root. We would let each factor equal 0. So to get from a factor to a root, we let it equal 0. To get from a root to a factor, we bring this number across the equals. We'll have x plus 4 equals 0, and then it's the x plus 4 is the factor. So if I know x minus 4 is a root, then x plus 4 is a factor. So in order to verify that it is a factor, I can then use my long division. So x plus 4, and I'm going to divide this into 2x cubed minus 7x squared minus 42x plus 72. So this goes 2x squared, so 2x cubed, so 2x squared by plus 4 is plus 8. x squared, do your subtraction. I'm going to put minus 15x squared, so minus 15x minus 15x squared. So bring down the minus 42x. So I have minus 60x. We do our subtract, so that becomes plus, this becomes plus, so that gives me plus 18x, and so plus 72, and this goes in plus 18 times, plus 18x, plus 72, and then change my signs, 0. Therefore, x plus 4 is a factor, since it divides in evenly, which again was no remainder, and since x plus 4 is a factor, therefore x equals minus 4 is a root. Okay, so that's the first part done. Now, obviously, so I suppose, let's say, so this is method 1, and this is method 2. So you're looking at this saying, well, method 1 is clearly the easier method. Of course I'd be doing that. However, we're not just asked to show that x equals minus 4 as a root. If it stopped here, if that was all that was asked, method 1 would definitely be the easier method. However, because we have this hence find the other two factors, like in the previous question, we need to use this piece here. Now, obviously we need long division to do that. So if you use method 1, you still are required to do the long division that appears in method 2. So actually there's extra work. If you like to use method 1 and then do your long division, that is absolutely fine. If you are happy to do that, if you want to just use method 2, that's absolutely fine, as long as you're clear. I wouldn't jump straight into just doing your long division of x plus 4. Because you need to verify, or you need to back up why you're doing that. You need to be clear, you know, x equals minus 4 is a root, then x plus 4 is a factor. And when you do your kind of summary at the end, you need to explain why. So then the hence part here, so I know it's getting a bit messy here. So we have 2x squared minus 15x plus 18. So we need to do our factorization. You could use guide number, and that's absolutely fine. You should, if you use your guide number, end up with 2x minus 3 and x minus 6. So then, therefore, your factors are going to be x equals, apologies, so sorry. So your factors are going to be x plus 4, 2x minus 3, and x minus 6. Now, if they wanted the roots, which were not asked, but if you were asked the roots would be x equals minus 4, x equals 6, and then you have x equals 3 over 2, or 1.5. So both of those are quite simple to work out. So regardless of how you want to show that x equals minus 4 as a root, you do have to do that long division. Be careful with making sure that you answer the question and you show that, yes, I understand what I'm being asked. I'm not just blindly doing long division because that's what I was told to do. So make sure you have a good understanding of how we can write in the answer. So just using the 3 dots for therefore. And all you're saying is it is a factor because it divides in